We are looking at what relations represent functions, ordered pairs, mappings, diagrams, tables, and domain and range. So the first thing we're going to do is graph some ordered pairs to ensure that we know what are ordered pairs and how do we graph. So when you graph an ordered pair, you graph it as x comma y, where the x is on the x-axis and the y is on the y-axis. So that first point, -4, -8 is going to be to the left 4 on x and down 8 on y. Then you're going to graph 3, 6, so to the right 3 and up 6. 0, 0 is a special point. That point is known as the origin. So again, 0, 0 is a special point. It's known as the origin. And then we have -1, 3. That's in quadrant 2. And we have -6, 5. Okay, so again, when we're graphing, we graph x comma y. A graph or ordered pair is a representation of points. These 5 points graphed together are known as a relation. So the set of points graphed together is known as a relation, which leads us into our definition. A relation is a set of ordered pairs. A relation is a set of ordered pairs. We have 2 types of relations. We have discrete and continuous. So a relation is a set of ordered pairs. We have 2 types of relations, discrete and continuous. A discrete relation is a relation in which the domain is a set of individual points. A continuous relation is where the domain is a relation in which there is an infinite number of elements and the relation can be graphed with a smooth line. The domain is the set of inputs. Oftentimes, these are the x coordinates. The domain is the set of inputs. Oftentimes, these are the x coordinates. A range is a set of outputs. Oftentimes, these are the y coordinates. So we could be given a set of ordered pairs and told to graph each relation. So the point 0, 4, -2, 3, -1, 3, -2, 2, and 1, -3. Now, when I graph this relation, we want to identify a few key parts. What is the domain? Well, the domain is the set of the x values. What is the range? And then, is this discrete or continuous? So your domain is -2, -1, 0, 1. Remember, a domain is a set, just like the relation, so it gets brackets. A range is a set of points as well. It's -3, 2, 3, and 4. And when I look at these points, I can't really connect them in a nice, smooth way. I even have 2 points here that are in the same line. So this is a discrete relation. Number 2, we have -2, +1, -1, 0, 0, 1, 1, 2. So my domain is the set of x's, which is -2, -1, 0, 1. My range is the set of y's, 0, 1, 2. And this function looks as if I could connect it nicely. I could draw that line in there, connect my points. So this is continuous. Okay, rate the ordered pairs for the relation. So now we're taking the points on the graph and creating the relation. So again, it's a set. We write them as coordinate points, so they go in parentheses. So we have -4, +4. I like to go left to right to try not to skip a point. -3, -2. -2, 4. To -4. And 3, 2. So my domain is the x values. My range is the y's. So you could maybe connect these points. They don't necessarily have a pattern. But because you could possibly connect them, it would be continuous. And number 4, -3, 2, 0, 1, to 4, and 4, negative 3. Okay, so 1, 2, 3, 4, 4 points on the graph, 4 points in my relation. Identify your domain. Identify your range. And again, it may not be the prettiest, but you could connect those points, which would make it continuous. Okay, the second type of relation we have is a mapping. So I talked briefly about mappings in chapter 0. A mapping is where you take a set of ordered pairs and we create bubbles where we map the domain to the range. So the first thing we're going to do to set up our mapping is create the domain. So our domain consists of -1 and 1. Then we're going to set up our range, which is 3 and 7. And then we're going to create a mapping from the domain to the range. So this first point tells me -1 maps to 7. +1 maps to 3. 1 maps to 7. And -1 maps to 3. If we recall, and what we're going to talk about tomorrow, in a mapping, if more than one point goes from the domain to the range, it is not a function. So tomorrow we're going to talk about what is a function. But if we look at number 1, we should be able to tell that is not a function. Number 6, our domain is 0, 1, 2. My range is 2, 3, 4. 0 maps to 2. 1 maps to 3. 2 maps to 4. So my relation is a function because for every x, there's only one y. Okay, and then in number 7, our domain is -2, -1, 0, 2. My range is 3, 5, 8. +2 maps to 8. -1 to 5. 0 to 8. -1 to 3. And -2 to 3. So in order to be a relation, every value in the domain must map to at least a value in the range, and a range must map to a domain. Okay, your homework is on page 65. You're doing 4, 14 to 17, and 23.